a very technical lesson. You need to really know your stuff to be able to do this lesson. You have to know the entire transformation unit to do this lesson. That's good. If you know your transformation unit, good. We get to review it again. It's bad if you still don't know it, because now you can't do this objective. So if you don't know it, or you're still a little, or you've forgotten it, you need to get that study sheet out. Now, I want you just to look at the graph of y equals log 3 of x, or 3 to the x, okay? That's what the graph looks like. Now, here's some things to be able to see. First of all, what would be look at this, let's go right down to here. It wants us to fill this in. Okay, what would be the domain of that graph? What would it be? Is x in the reals? X is greater than 0. Okay? Now, can anybody tell me in calculus how to write that in interval notation? Open brackets. Round bracket or square bracket? Round bracket. Okay? So, I have heard that they can throw interval notation on the diploma. Why? Because it is touched on in grade 10. In fact, now that we know this, Ms. Johnson is going to do a bit more interval notation in grade 10. Okay? It's not in the grade 12 curriculum, but the diploma tests your last 12 years, right? I'm just the one that get blamed if you don't do well. They will go to your other teachers. They're like, grade 4 teachers like, okay, guys, see you later. Now, what would be the range of this one? Y in the reals. And in interval notation? Okay. A curved bracket always goes with infinity or negative infinity. Okay. And a square bracket goes for greater than equal to or less than equal to. Round bracket just for less than or greater than. It's actually a pretty simple notation. You actually did do some in grade 10, believe it or not. And those people in calculus, people in calculus do have an advantage on the diploma because they're doing twice the math as you. They will know some more advanced stuff, so, statistically they will do better on the diploma because they're doing twice the math, right? No. Okay? Now, what would be the x-intercept? Y-intercept? None. Asymptote? X equals 0. And what is the value that makes y equal 1? Now, this should make sense. What value in here would make this equal 1? 3. So 3, 1 should be a value on here, okay? So I want to come up here and let's just, 3, 1. Now, why is this valuable? Well, where would log 10 of the x, 10 to the x, where would you think? 1 point for sure that's going to go through. 10, 1. And it's going to go through here as well, right? So then we can start doing something like this. So what happened? Back to our transformation unit. Vertical stretch, horizontal stretch, what do you think? Could be a vertical stretch. Also, could be a horizontal too, because when you pull things, they do get narrower. Okay? So, vertical or a horizontal. Okay? And we're going to have to get into that. Now, here is kind of so we said tan 1 for y equals log tan of x. Okay? Now, the question that I would like now to go to is y equals log 1/3 x. What would make that equal 1? 1/3, okay? So here's a point. Okay, here's like 1/3 1, right? There's 1/3 1. So right now, are we picturing maybe this kind of graph? Why would it be a reflection? Okay, it is a reflection. Still has to go through 1. So if it was a reflection, should look something like that, hey? Now, how could you prove that log 3 to the x is a reflection of log 1/3 to the x? Now, this is beyond impossible if you don't use your transformation unit. But can you tell me what, in an equation, what makes something flip on the x-axis? Y going to negative y. So we should, so can we go up to the top where there's maybe a little bit of room? We have y equals log 3 to the x. And we are doing a reflection on x-axis, right? Now, according to what we've learned, if this is going to be consistent, y should have been replaced with negative y. Now, what's my goal? I want it to make it look like y equals log 1/3 of x, right? Because that's what it shows in the picture. So let's start and see how this is going to go. Now remember, you got to know where you're going, or else this is just like a waste of time. So I know what I want it to look like, but I can't miss any steps. Okay, if you're telling a story, you leave a couple things out. You're going to see a lot of confused people going, oh, who's John? Why did he go there? So next, I can make this y equals negative log 3 to the x, right? Okay. What do I do next? How am I supposed to get this to 1/3? How do I mess with that little thing in there? Bring the negative 1 on top. What do I do now? Now it's kind of like mind-boggling. I don't know how to get that negative down there. Yeah. Okay. Hmm? Do what again? So you want to go y equals log 1 over 3 to the negative 1. What do you want me to flip? That won't work. Yeah. No. X to the negative 1 does not equal negative x. Yeah. Yeah. So I'm not trying to waste your time here, but a lot of people would go this route that I went, and you're just like, you get stuck, right? So right at the beginning here, if we change it to exponential form, let's try that. That would be 3 to the negative y equals x, correct? Now you might start to see this. Now, that's the same thing as, and I'm going to do this step so I don't lose anybody. This is the same thing as 3 to the negative 1 times y to the y equals x. I haven't changed anything, okay? But I'm allowed to separate the negative and the y. Because we were always told, like, if that was 3 to the 6, that's 3 to the 2 to the 3. Right? 2 to the 3, 6. So now, what is 3 to the x? Or 3 to the negative 1 is the same thing as 1/3 to the y equals x. And now I will change it back to log form. Log 1/3 of x equals y. So I have proved in that when you take y and replace it with negative y, it will make the base 1/3. That is a reflection on the x-axis. Okay? Now that's something that you kind of just need to start to know. If you ever get lost, you can prove it, or you can go there. But let's talk about the domain and range of it. Okay, you can see it there in red. What would be the domain? X is greater than 0, or 0 comma infinity, 0. What's the range? Does that change? No. Y is in the reals. Negative infinity, infinity. X-intercept, still 1. Y-intercept, none. Asymptote, x equals 0. The x value in y equals 1. Well, that's where you're going to get your 1/3, comma 1. Okay? So if you just look at what you've written on the top of your page there, or maybe you wrote it on the bottom, there's a lot of stuff to know. You have to know your exponential to log rules. You've got to know, oh, if it's a reflection on the x, then y must get replaced with negative y, right? And some of us are even taking for granted probably that we know that stuff. But there was a time where you guys were not loving that stuff for sure. So how do these compare to each other? Well, we already showed that. They're a reflection on x-axis, right? AKA, y is replaced with negative y. Okay? We don't have to go through there. So, the moral of the story, I guess, is when you have the graph of y equals 1 over b to the f, that is a reflection in x of the graph y equals log b of x to the n, or bx. Okay? Now, Also, you have to remember this below, that y equals log 1 over b of x is equal to negative log b of x. Okay? So if you take the negative away, they are reflections of each other. If you put that negative in there, they're equal to each other. Now, if you do the next one, now, first of all, we have this to change into exponential. So I would say 4 to the 8 equals x. Well, now that's so easy. I can just put that into my calculator and I'm good to go. Now, if I was doing this, I might go like a number that your calculator gives you an error, because I'd like to solve this without a calculator. Because this, change it to exponential, and this here, like this is two things that I know. They really harp on, so that gets you to know this stuff. So I'm looking at this, and I'm looking at, hey, if I had that 1/4, the 1/4 to the n, so, and I could actually put this if I wanted to. Maybe that's more relevant here. Log b to b to the n, the third level, is my answer. So, well, what if I made that log b to the b? Well, hey, I got 4 to the 8. This is the same thing. 1/4 to the negative 8. So now, if I put this into here, I would have log 1/4 of 1/4 of negative 8. My answer would be negative 8. Okay? So my exponential log got me out of trouble, and then knowing b to b to the n equals n got me out of the second bind. Okay, now let's talk about, we got reflections on the x, let's talk about stretches. Okay, now stretches can be, again, pretty confusing. If you know your rules, though, just stick to them. Now, at the top of your page, I want to have like 2 levels here, so it's going to be kind of squished. But if you had y equals log, and you have more room on the bottom or the top, not really that good. All right. Okay. Find a spot even on the side or whatever. If you had y equals, and in fact, these wouldn't be bad working down. If you had y equals log b to the x, and say you do a vertical stretch by 1/3 on that graph. Okay, if I was to do that, what's the replacement? What is it? Y goes to 3y, right? Remember that? Now, let's do it. So that would be 3y equals log b the x, which is the same thing as y equals 1/3 log b of x, is the same thing as y equals log b x to the 1/3. Okay? So if you did a vertical stretch by 1/3, your third level can be 1/3. Okay? So I need you to, not maybe memorize this, but see how I can take that 3 and move it throughout the equation. Now, that one, I think, is a lot more intuitive than the way I'm also going to show you what also equals a vertical stretch by 1/3 would be if I, after this, would have went in this direction. Well, let's change it to exponential. So that would be b to the 3y equals x. So I can do what I kind of did last time. This is the same thing as b to the 3y equals x. Remember, power to the power, 3 times y, still 3y. Now I can change it to log again, and I would have log b to the 3, x equals y. So do you see that the exponent on the b, so the 3 is not second level. This is all first level. This is all base right here, okay? It's all base, b to the 3. So if you cubed my base, that would be a vertical stretch by 1/3. Right? If you took my log and made it to the 1/3 power, third level, then you have done a vertical stretch by 1/3. Okay? Lots of rules to know, right? Now, if you come down to this chart, this here, if we had log b to the x and log b to the n to the x, it's a vertical stretch by 1/n. And so is this. Log b to the x equals, see this n here? You can also have it there. Or actually, more importantly, here. But when you have the 1/n in the front, that is, it really belongs on the other side to the n, and then we go 1/n. Now, what we're going to do is we're going to do a couple of questions here for you to understand kind of what's going on. Now, if we have log 3 to the x, but it goes to log 81 to the x, what was the transformation? That's a tough question. It's pretty short. It's like 10 words. How can it be that hard? It's hard. If you know what you're doing, under a 1-minute question. Anyone want to throw out an idea? Yep. Vertical stretch by the factor of 1/4. Okay, let's do number 2. Just kidding. How'd you get that? Okay, can I stop you there then? So we did have this, and we went to this. Y equals log 3 to the 4, the x. Now, what? Is this a vertical stretch by 4? This is a vertical stretch by 1/4. See? Not even a 1-minute question if you know what you're doing. And that is this unit. I will have people bouncing their pencil in their nose for like a half hour on the next exam, and I'll have some people that will not finish. Because you'll struggle and you'll try many ways to go through this. But if you kind of have been, if you know all your rules, they're pretty fast. Okay, let's do number 2. This was the original, the before. This was the after. See, that even messes with our heads because they're like, what? 16 to 4? What? Okay? Always make the bases the same. What would we do? Now, we have to serve two masters here. This here has to still equal 4, and I need the base to be 16. 16 to what power is the same thing as 4? Half. Right? So y equals log 16 to the 1/4 and x. Okay? And remember, 16 to the 1/4, I'm going to write, I hope I'm not writing too small, okay? 1/2, sorry. 16 to the 1/2 is the same thing as 4. So what have I done here? Well, I did what you have to do. I made the base both 16, but I can't just go change the question. If you change the question, I think you're now going to get a different answer. So I haven't. But then this is a vertical stretch by 2. Again, a very, very good multiple choice / numerical response. Yep. Horizontal stretches in there. I think a vertical stretch by 4 would be an excellent distractor because people are going to go 16 to 4. Easy. Multiply by 4. Right? That would be one of the best distractors, I think. Well, we're going to be doing some diplomas, and you'll get to see how they don't come out and just ask for the answer. They want to know a thought process. Okay, this is a really good diploma question. Actually, it's not that tough. This one, like I could just convert this to exponential and then plug it in. That one's easy. But let's do it using kind of the transformations that we know. Or actually, we don't need transformations. But I want to make this log 5 to the x. How can I do that? Because I know that log 5 to the x equals 6. How can I make this one log? What is 125? So this would be log 5 3x, right? Now, from what we know, this is the same thing as 1/2 log. But yes, sorry, 1/3. That's I can't read my own writing. Okay, 1/3. That's from the rule that I just gave you. And I could go through the proof again, but you do have it written on the top or the side of the page. See, now it's easy, because what is 5 to the x? Log 5 to the x. 6. This is 1/3 times 6, right? Because I know that this is 6, so the answer is 2. Okay. The next one, great diploma question. Okay. They would say log 3 to the x. They gave it to you. And then they would give you 1, 2, and 3. Do you see them down there below? Y equals log, 2. Y equals 2 log 3 to the x, y equals log 3x minus 2, and y equals log 3x minus 2. And they would ask, which ones would not result in a change in domain or range? Okay? And you may be thinking, oh, I'll just graph it. But sometimes they would say f of x log, whatever, right? So you don't even know the graph. And they probably wouldn't give you the picture. They'd say which ones. So they would say 1, B might be 1 and 2 only, C would be 1 and 3 only, and D would be 2 and 3, or all of the above, right? Those questions, you're just like, that sucks. I mean, I got work to do. I got a lot of work to do before I even can go and answer that question. Now, it would be good to actually know the domain and range right now, and that's why the picture is pretty valuable. What's the domain and range? So let's write this out here. This is log 3x. Y equals log 3x. What is the domain and the range of that? What's the domain? X is greater than 0, and the range? Y is in the reals. Okay, it's kind of nice to know what it is now, because if it's going to change, well, it's kind of irrelevant if I don't know what it was in the first place. Now, can anybody tell me what this is? What transformation? Who does the 2 belong with? So this one, I would take the time to go like this. So now, let's do a replacement. The replacement would be y got replaced with 1/2 y. So what is the transformation? Vertical stretch by 2. Okay? Now, think about it. Word is picture. Remember? Pictures with 1,000 words. Remember that. So, if I took this and went, would it change domain and range? Okay, so I am going to not say it will not change. I will just say the domain would be x is greater than 0, y is in the reals. Okay, great question. And again, you got to really think. That's just not like, hey, what's 2 plus 3? Okay, 5, go on to the next one, yay. You know, they're always getting you to think about domain and range. The next one. Remember where we came from. Y equals log 3 of x. What changed? What got replaced? X with x minus 2. That is a 2 units right. Okay, so we got to picture this. Let's move it 2 units right. What would be the domain? Right. Domain x is greater than 2, and the range lies in the reals, right? Okay, number 3 looks very close to number 2, but it is going to be a different graph than number 2. Okay, the negative 2 belongs with y, and do you see how it's obvious it belongs with the y? Okay, it will always be obvious. It will not be in brackets. So that would be y plus 2 equals log 3. Yeah. So x got replaced with x plus 2, which is a y got replaced with y plus 2. Yeah, I know. Okay. So down 2 or up 2? Down 2. So vertical translation down 2. Remember how it used to be so unfair when they took stuff from other units and used it? That wasn't even fair. It's not fair. Okay? Remember, life's not fair. We just learned that right here. So, domain. Look at that graph. Move it down 2. What's the domain? X is greater than 0. Range. Y is in the reals. So 1 and 3, domain and range don't change, right? 2 is the only one that changes domain and range. Kind of a hard question, I think. Yep. Yes. Someone asked, can you ever change the range? And I said, yes, if you did a reflection on y equals x. You would change the domain and range if you switch x and y. That's the only transformation. Oh, well, actually, no. A reflection on the y would also change it, right? Goes to the other side. That would change domain and range. A reflection on the x would not change domain and range, right? So they love to do questions where they're combining 2, 3 units. And I know you guys love them too. Deep down. You're just scared to show it. Scared to show your feelings. Because you'll be vulnerable. It's okay. You're safe in here. Josh, you're safe. Okay. Okay. Now, this is an awesome question. Okay. This is something, here's a plug for the book. This is why I love this book so much. You would never see this in a textbook, but you would see this in a diploma. Okay. The diploma is all about, come on, let's take this to another level and see if you can think outside the box and get this one. One of every unit's got to be on there like that, right? Well, this book is proactive enough. They've thought of everything pretty well. I mean, they can't get everything, but they've thought of things that they might throw this in the diploma, so let's go over it, right? So instead, you'll be going to the diploma and going, okay, I saw that. Now, we are talking about this here. Y equals log x to the n and n log x. Those are identical, right? Remember, that's third level. Both those, or that n is third level because there is invisible tens there. Now, they're not invisible. They're red. So, we've learned that many times. N, front, top, whatever. Now, let's talk about odd and even values of n. Okay, so you know what odd are, right? 3, 5, 7. We're not going to use 1 because, and then even values 2, 4, 6. Something extremely unique happens when you have your exponent, or that 3. So let's look at n equals 3. Okay? So n equals 3 would be called an odd. So let's graph y equals 3 log x. Can you actually do that in your calculator? Y equals 3 log x. How would you do that? Just like it says, okay? You don't have to get fancy. Y equals 3 log x. Okay, and you should get something kind of looks like this, right? Now, let's do the identical thing. Y equals log x cubed. Right? We learned that. We're allowed to do that. Okay? So graph that into y2. And x cubed, make it one thing. So x, little house, roof, cubed. Do you get the same graph? Yes. Okay, well that's good, because that's what we learned, right? I hope I'm getting the same graph. Now, let's do n equals 2. So this would be called an even. So that would be, let's try the first one, y equals 2 log x. Okay, so you can go back to your graph, y1, and just change the 3 to a 2, and then let it graph. Again, you get something like that, right? Now, put in y equals log x squared. To get the same graph. Okay. Now, the important thing now is to understand what happened. Why that rule, like we learned it. I thought that was like a good rule. It's been working good in the homework. I'm getting it. I got it on the quiz. Now you're saying the rule doesn't even, like, they're not giving the same graphs. And you just told me that I could y1, y2 it, and I should be able to get my answer. What is happening here that is making this inconsistent? What's an explanation? What kind of x's are we allowed now? You're allowed negative x's, but I am not allowed a negative in a log. Because if you look at what is the domain and range of any log x, x has to be greater than 0. If there's a negative in there, it doesn't work. Well, why is it working now? Because of the squared. The squared is getting rid of the negative before it gets logged. That is why you're allowed all those negative x's too. Okay? So, that is a huge thing to know. That is going to be one question of the diploma. They will say, like it could even be, when does y equals log n, n log equal this? Provide different graphs. Okay? And it may be, when you change the base, they're going to say, doesn't work though. It is when you change the n. Okay? So, what's that? Just like this. If n is odd, y equals n log x is identical to the graph y equals log x to the n. So if n is odd, those two graphs will be the same. Okay? If n is even, y equals log x is not identical to Okay, you guys have like way more time than the last class to do your work. So we got 1, 2a, 3a, 5 to 9, and 11 to 17. It looks worse than it is, but it's fast stuff. It's just going to ask you questions, fast, quick questions. Remember, if you know this stuff, it is very fast to do your homework, okay? But again, you have that book on your desk that has answers in it. Check each one of them so you're learning as you go along, and make sure you have a study sheet that'll help you tomorrow.